Good evening to all. Today's our class subject is cable management. That is the power and control cables of the locomotive. What is cable? In an electrical and electronic system, a conductor or a group of conductors for transmitting electric power or telecommunication signal from one place to another, that is called as cable. In our side, it is electrical cable, not a telecommunication or signal cable. Today we are discussing about electrical cable, which is used to carry current from one equipment to another equipment or from one source to one load. This is a cable. Inside these strands are conductors, and outside you can see that is insulated sheath is there. Normally our locomotive cables, the standard color is black and its maximum continuous temperature is 120 degree, and recently it is revised to 150 degree as per the latest specification, and the minimum continuous temperature is minus 40 degree. Normally that much negative temperature will not come, but it is designed and its specification is minus 40 degree, and the normal voltage rating of the normal cable used is 1.8 or 3 kV. There are certain cables which should work at 4 kV, that also is there, that will come in the next page. The cable design. Normally that cable specification is there, CLW bar ES bar 3 bar 0458, that is the specification, and its alteration E is now used. In that, the testing voltage is mentioned in the first letter, that is 3 GkW, 4 GkW, 9 GkW. The 3 GkW is normally tested for 600 volts, 4 GkW is tested for 3000 volts, and 9 GkW is tested for 4000 volts. The G is mentioned for electron beam cross-linked insulation. The letter G in the cable specification is for its cross-linked insulation method. The K is for cold resistant and W is for heat resistant. That is, you can purchase 3GW or 3GK, like that different cables are available, but it is not there in locomotive. The 4 GkW, 3 GkW and 9 GkW, three types of cables are used in WP7 and WP5 and WG9 type 3-phase locomotives. The screened cables are mentioned as EMC screen is there, then we will mention it as S, or S is for multi-core and the screening is there for, then it is mentioned as EMC. The S is there in certain sensor and all, some S is there, that is multi-core cable. That is specification is CLW bar ES bar 3 bar 0459, a different specification for multi-core cables. Other letters are normally not used for our loco, that is RW, that is reduced wall thickness, DW for dual wall thickness, MW for medium wall thickness. Like that we are using these types of cables, that is 0.5 square mm cable for VCU input. Most of the VCU inputs are connected from 0.5 square mm. Its color is red or yellow. In our locos it is red cable only. It is 3 GkW only, and 1 square mm it is used in some circuits only, very less only. Whereas 1.5 is there in most of the circuits, 2.5 is there for almost all the control and many auxiliary motor circuits. Next is 6 square mm is there, 10 is there, 16 is there, 25 is there, 35 square mm is there. This 25 and 16 are used in OCB and TMB circuits. 35 is there in HB panel. From bar 1, bar 2, bar 3 output cables are this 35 square mm only. Next is 50 square mm, 70 square mm, 95, 120 and 150. This in this you can see 4 GkW 120 is there, and same 9 GkW 120 is there, like that 9 GkW 150 is there. This is 9 GkW, that is 4000 volt rating is there. 4000 volt rating cables are used mainly in traction motor circuit and SR input area, that is high voltage area, mainly coming from transformer and connected to traction motor, because traction motor voltage is above 2000 2180, that is 2180 volt is there. That's why we are using higher rating, that is 4 kV cables are used. Different size of 9 GkW cables that are used in locos are this, that is from 10 to 150 square mm. Screened cables in loco. That is 2 pair plus screening into 0.5 is there. That is 2 cables will be there and the screening will be there. Its corresponding drawing number is mentioned there. Like that, 3 is there, 5 is there, 9. 2 into 2 is there, that is the 4. In that 2 into 2 means 2 will be twisted and another 2 will be twisted. Like that it will come, mainly coming in sensor cables. Like that 3 into 4, that is 3 cables in 3 pair of 4 cables. That is 4 will be in a bunch, again 4 will be in a bunch, another 4 will be in a bunch. That is total 12 cable plus screening will be there, and its cable size should be 1 square mm. Like that, different size cables are there in locomotive, mainly in 3-phase locomotive. We will go to the cable condition. That is cable analysis, failure analysis. Look into the history of records or records of failures in the past to see whether there are any common factors or location. That is, in case of a cable failure, before analyzing, we have to check the history. That is, whether similar type failure was there in the similar location earlier. That means there may be a design defect or some cable bunching defect may be there. Cable may not be the reason. Maybe the design may be the reason. Like that, we have to analyze. Look for the presence of factors that accelerate degradation of insulation in the vicinity. Any reason, that is moisture entry, water entry, heavy dust, all these factors will affect the cable insulation. So that also may cause a cable failure. Ensure that there is no direct contact between the insulation of any cable and any metallic structural member. In case of a cable failure, there are high chances that a metallic object, maybe a cleat or a sharp edge or a bolt or a projected metallic piece, something may be hitting on the cable insulation, and due to the continuous running of the locomotive, that insulation may get punctured and that will cause a cable failure. Ensure that the cable cleat grooves are dimensioned in such a way as to grip the cable firmly but not too tightly. That is, all the cable should be bunched so that there should not be any vibration to the cable on run. But it should not be too tight that it will press the insulation and the insulation also will get damaged. That much tightness should not be there. That means a positive gap should be maintained in the cleat. Confirm at the same time that there are no spaces left to permit cable vibration within the cleat. That is, on run, the cable should not get vibrated. That is, if there is a vibration, there are high chances of insulation failure due to vibration. To avoid the vibration, we have to provide insulated cleats, that is SRBGF insulated cleats at different locations, and it should be in such a condition that it will not hold too tightly or it should not be too slack. It should be in such a way that there should not be any vibration and the cable will be there in a free manner and without vibration. Different specifications which are used in our locomotive. Our 3-phase locos, these 2 specifications are used. That is first 2, that is CLW bar ES bar 3 bar 0458 and 0459. These 2 specification cables are used in 3-phase locomotives for all the control and power circuits. For conventional locos, that is WP4 and WG7, the specification is different. That is spec E14 revision 2 for elastomeric cables and spec 0019 revision 4 for thin-walled E-beam irradiated cables. These 2 specifications are entirely different and its manufacturing process and everything is different. Now we will go to important letter, that is Fire Prevention 2006. This letter is very much important while considering a locomotive. There are high chances of getting fire in a locomotive on run. To prevent that, RDSO has conducted a study and submitted a report in 2006. We will go to that letter and important points will be discussed. Ensure that the edges of the cleats are rounded so as to prevent cutting into the cable insulation. That is, all the cables in the cable trench or wherever we fitted should have proper cleats, and the cleat edges should be curved or should not be sharp. That is, it should not cause any damage to the insulation of the cable. Ensure that there is no localized overheating of the cables due to external heat sources such as steel plate heated by eddy currents, resistors, steam pipes, etc. That is, the cable should not get heated due to any external factor. That is, in locos, that AC circuit is there, that AC power cables are coming from transformer to rectifier block, and there are high chances of eddy current if the cable is pressed or secured using a metal cleat. To prevent that, we have to provide SRBGF insulated cleat so that the eddy current will not be there because the circuit is not completed. That magnetic circuit is not completed. Ensure that dissipation of heat from the conductor is not impeded by the accumulation of dust. We have to ensure that the cable tray or cable trenches are not so tight or not accumulated with much dust, because much dust is there that will cause insulation failure and cable insulation failure and loco failure. Ensure that the lubricating oil or other chemicals are not allowed to come in contact with the cable insulation. This is an area where compressor oil may get spilled on the cable and that will get accumulated there itself in the cable trench. Due to long run, the compressor oil accumulation on the cable will cause insulation failure to the cable, and later on that will cause a failure or fire. Like that, the transformer oil also spilling on the cable will cause insulation failure on a later stage because of accumulation of oil on the insulation. Select cable ratings after taking into account that local ambient conditions and the proximity of other heat generating devices. Normally, for cabling in a locomotive, all the cable dimensions and its rating is given by RDSO, and CLW has issued necessary cable index and circuit for using in the locomotive. So we have to use the standard cable rating as prescribed in the circuit or index only. We should not reduce the cable rating which is mentioned in the drawing or the circuit. We have to use the standard only. The main thing we have to consider is, for any cable there is an important factor, that is derating factor. Derating factor is the rating of the cable will get reduced if it is provided in a cable trench or in a concealed area. If we are putting a cable in an open area, if it is rated for 100 amps, it will take 100 amps without any problem or without getting heated up. If we are exposing that cable to some heat or high heat area, there is a chance to reduce the capacity of the cable. Especially if we are providing a fully loaded cable in a concealed or in a tube or in a cable trench, and it is fully covered, means the capacity to carry the current will get reduced. Normally the derating factor is some 0.8 or 0.7. The standard rating, if we assume as 100 amps, if we have to take the derating factor as 0.8, then the capacity the cable can carry will be, we have to multiply 100 into 0.8, that is 80 amps only. We have to, if we want to carry 100 amps in that location, we have to use higher size cable, otherwise that cable will get heated up and that will cause a fire. To prevent that, always ensure that a designed cable size is used in the locomotive. We should not reduce the rating. If required, we can use the next higher size. That is, we have to provide a 10 square mm cable, whereas that cable is not available, then we can go for 16 square mm, not to 6 square mm, based on the availability and the space to provide. Consider the possibility of overheating of terminations when investigating the cable insulation failures. Wherever there is a cable insulation failure, we have to analyze the cable crimped area also for the reason, because there are high chances of cable getting overheated due to poor contact in the crimped area. Use of this is from the letter from 2006 letter. Use of spelling wrong. It is elastomeric cable and thin-walled cable should be strictly as per RDSO specification only. We have to use RDSO specified cables only. We should not purchase any local market cables One thing is local market what you get is PVC insulated cable only for house wiring. It is not a tinned cable. Whereas in locomotive all the cables are tinned cable only for life and to prevent sulfation. Because local market tinned cable is not there because its cost will be very high. So we should not use any cable from the local market. We have to purchase from RDSO approved suppliers only. That also as per the RDSO specification only. While laying or replacing the power, auxiliary and control cable, sharp bend to be avoided in cable laying. There should not be any sharp bend in the cable because in the sharp bend there are high chances of insulation breakage and thermal overloading also. Use of neoprene based rubber sheet, rubber insulated sheet should be extensively used for protection of cables against mechanical damage at the bends or at the critical locations where there are chances of cables coming into contact with the sharp edges of locomotive metallic part. This we already discussed, that is wherever there is a cable we provide, we have to provide sufficient rubber packing to prevent any insulation damage on run. All the cable cleats should be SRBGF, that is silicon resin bonded glass fiber. Its IS specification is IS 10192 UP1 grade. That specification SRBGF cleat only should be used in locomotive, and we should not use any other cleat, that is PVC cleat or metallic cleat or any wooden cleat. You should never use because wood is very prone to fire. So we have to use SRBGF only, not any other cleats. That SRBGF, there are certain approved agencies who got approval from CLW because they have already tested their material quality and all, and we can believe their test. Then also we have to give the sample to our lab to ensure that it is as per the original specification and IS specification. For the cleat and all, CLW has prepared separate drawings, and we have to use the cleats as per the CLW drawings only. In no case use of wooden cleats, wooden supports or any other wooden or backlight material should be used in the vicinity of the power or auxiliary or control cables. Wooden we should not use because it is very prone to fire. All cable cleats must be checked for presence of positive gap in full tight condition. That is, there should be a positive gap, that it should not be too tight but it should not be slack also. That cable should not move freely, that is the cleat should hold the cable but it should not be too tight to damage the insulation. Laying out of the cable should be such that the power auxiliary and control cable should not get mixed. That is, we have to provide separate cabling for power cables and control cables. In that, auxiliary cable also will come, that is cables to MEMT, MPH, MVSI, etc. All are 415-volt cables that we have to lay separately in the cable trench, and it should not bunch. It should not get bunched with the control cable, which carries 110-volt DC. If both are in a close vicinity, there are high chances of AC induced EMF in the DC circuit, and that will cause unwanted fault indications in the LED indication panel and unwanted fault creation in the FDCs also. So we have to keep both the cables separately in the cable trench. It should not get mixed. PVC cable bunching ties should be used as the wrapping straps for securing the control and auxiliary cables. Only cable tie as per CLW specification should be used. That is CLW bar ES bar 3 bar 054 specification is there, that we have to use. Different size cable ties are available and it is a stock item also. We have to use that cable ties only. We should not use non-standard cable tie for cable bunching and non-standard material also for cable bunching, because that will damage the cable and that is prone to fire also. Polyolefin heat singeable sleeve should only be used to cover the bare portion of cable and part of the cable leg or ferrule on power as well as auxiliary. In the end, where the cable ferrule or cable leg is crimped, we have to put a heat singeable sleeve. The sleeve is made of the material polyolefin that only should be provided at the end. We should not put an insulation tape and keep the leg in open condition, because later on that will cause moisture entry and sulfation. On the edges of the cable leg or ferrule and the heat sinkable sleeves, the use of self-use fire retardant insulation tape should be used to avoid any ingress of dust or dirt or moisture. That is, in the end, if the strands are visible, we have to cover using that self-using tape. During the major schedule, that is IOH, IOH or POH, all the holes through which the cable passes should be checked for sharp edges, burrs, and availability of proper size of grommets should be ensured in proper condition. That is to prevent any damage to the cables. In no case, the joining of the cable should be permitted even for emergency operations for short duration. That is, cable, if you don't have sufficient length cable, there should not be any straight joint using any ferrule. That is, a single cable we have to put from one location to another location. In between, if we want to put an opening, we have to put a SB terminal with the proper packing, with the proper fixing. We should not do any straight ferrule and insulation tape business in the cable, because there are high chances of sulfation and open circuit, and that may cause fire also. The cable layout should be in one piece and with end to end having proper legs. That is, both end cable numbering and leg will be there. In between, there should not be any straight ferrules. All cables of high voltage should have space in between to avoid tracking. That is, high voltage cable also should have properly bunched so that it won't get tracked in between. Due to high dust and moisture entry, there are chances of weakening of the insulation, and that may cause tracking. To prevent that, we have to provide sufficient spacing between them. Now we will go to the failures. This is a cable insulation failure in cable trench in one newly received loco. That is, the cable insulation was failed due to the sharp edge crushing on the cable. To prevent that, rubber packing is there, but rubber packing is not there where the requirement was there. To prevent that, we have to shift that cable a little bit toward that side, and we have to add additional rubber packing in this point. This is a cable failure. Another failure, you can see one cable bunch damaged due to sharp edge. Such type of cable damages may cause when improper tool is used. Instead of for cable tie cutting and all, proper wire stripper only should be used. Instead, if someone is using a knife or a axle blade piece and all, there are high chances of cable insulation getting damaged due to knife edge hitting on the cable side. This is a cable insulation, cable failure due to that excess current was flown or improper crimping was there. Here the crimped area is there. Due to improper crimping, that overheating occurred. Here you can see one stiffener is there. That stiffener is pressing on the cable insulation, and insulation will get damaged after certain days. During commissioning of the loco, there won't be any failure. After certain days, due to continuous working of the loco, that cable, there will be slight vibration and all, and that stiffener will continuously press on that cable, and that insulation will weaken, and one fine day that cable will fail. To prevent that, we have to reroute that cable. We have to reroute that cable to this side, and we have to provide additional packing in that area to prevent that rubbing in that joint. This is another cable leg crimping failure which caused open circuit. This is improper bunching inside the cable trench. So many cables were laid without proper bunching, that has caused insulation failure because there was no proper bunching. One cable was continuously rubbing in the cable trench, that has caused insulation damage and later on burnt in that cable trench. This is another cable junction which was having a crimping problem which caused melting. A simple solution for analyzing of the cable insulation, cable failure that we can find before the failure is thermal imaging. If we use the thermal imaging camera, we can identify the hot spots or wherever excess current is there, so we can identify and we can attend the problem so that loco will not fail due to cable or insulation or any other failures. This is another crimping problem. This is a non-standard crimping. These three books are very much useful in studying the cable failures. All the three books are available in Amazon and internet. This can be made use of to know more about the cables. Thank you.